Suppose the value of purchases made at a store follows a normal distribution with a mean of 22.5 and a standard deviation of 4.25. Okay, so remember that capital N means you have a normal distribution with the mean and standard deviation. So enter each of the following, including diagrams, and let X represent the value of a purchase. Suppose samples of 10 purchases are randomly selected. Sketch a graph of the SDSM with N equals 10. Okay, so remember, this is where you need to look at when you choose samples of size N. Now you're looking at an SDSM, sampling distribution of sample means, and the mean of the sample means equals the mean of the original. So this one is 22.5. And then the standard deviation of the sample means is sigma over the square root of N. So in this case, it's 4.25 over the square root of 10. So that gives you a standard deviation of the sampling distribution of sample means to be 1.34. Okay, so what you do to sketch a graph of that, you put the mean right in the center. It's an X bar axis because we're taking samples of size 10. So the mean is 22.5. And then you just add 1.34 several times and subtract 1.34 several times. And that'll give you 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean, and so on. So that is the graph of the sampling distribution when you take samples of size 10. In number 2, now you want to find the probability that a sample mean is less than 21. So if you choose 10 people, or 10 purchases, you want to find the probability that the mean purchase amount is less than $21. So that's where you convert your X bar into a Z-score and then find probability. So you calculate the Z-score by your X bar minus mu sub X bar over sigma sub X bar. So plug in your numbers, and this gives you a Z-score of negative 1.12. So you put that on a graph. Okay, so negative 1.12. We want to be less than that, so less than negative 1.12. So we're shaded to the left. And this you look it up in your Z tables, or use your calculator, the normal CDF, which I showed you in the normal curve chapter. And you get 0.1314 for that probability. And again, this is review, so I'm going to assume that you can go back and look at that and figure that out. Okay, next one, the probability that a sample mean is greater than 23.75. So if we choose 10 people, what's the probability that their mean purchase amount is greater than $23.75? Well, again, you convert your X bar into a Z-score using the same formulas up here. And you end up with a Z-score of 0.93. And I will point out now that, again, in the first part up here, we said sigma sub X bar was 1.34. The only reason I did that was so I could round it and actually label it on the axes up here. When you find your Z-scores, you don't want to round until you get to the Z-score. So don't use 1.34 in the denominator here. Use 4.25 over the square root of 10. And remember, you may need to, well, not you may, you will have to make sure that you have parentheses around that entire thing to keep it together. So the way I suggest you do these is do the numerator, press enter, and then divide by parentheses 4.25 over the square root of 10, and then end the parentheses. Okay, so on a diagram, and when I say show all work including diagrams, this is exactly what I'm talking about. Make sure that you draw these diagrams each time. So in the second one here, we want to be greater than a z-score of 0.93, so we're shading to the right. So when you look up 0.93 in the table, it gives you 0.8238. That is the area to the left, because remember your table gives you to the left area. You want to do 1 minus that to find the area to the right. And then finally, number 4, if 10 purchases are randomly selected, find the probability, the mean purchase amount. And remember, when you see mean purchase amount, that's X bar. So that mean amount is between $22 and $25. So this is how you would write that in mathematical notation. So now you need to convert the 22 and the 25 into a z-score. So I show that over here. So an X bar value of 22 will give you a z-score of negative 0.37, and then a X bar value of 25 will give you 1.86. Okay, so on a diagram, now you're looking at z-scores between negative 0.37 and positive 1.86. So when you look up 1.86 on the table, you get 0.9686. And then when you look up negative 0.37, you get 0.3557. You subtract those to find the area between them, and that's 0.6129.